Good afternoon and welcome back to the 22nd annual CERIAS Cybersecurity Symposium. It is my pleasure to introduce our first panel discussion of the event. But the idea of this panel discussion came out of conversations with a number of our partners, two of them who will be participating in this panel discussion. And as mentioned earlier by our director, Professor Dong-Young Shu, is that he often refers to these areas as cyber plus. Cyber alone doesn't really matter. It's cyber plus. And so cyber plus aero is an area of great concern by many within the aero industry, the travel industry, and can be expanded to astro and train and everything else within that area. It can broadly be even expanded out to almost anything that is cyber physical. But certainly there are some unique attributes to the aero industry when it comes to cyber. We joke that as important as cyber automotive is, if there is a problem, you can pull over. It's a little difficult for an airline to be able to pull over if they're having a cyber incident in flight. So with that, it's my distinct pleasure to be able to introduce our panelists. So John Bush, who is the product security engineer at Boeing, Michael Gahn, the Chief of Technology for Product Cybersecurity at Rolls-Royce, Professor Berti Selig, who's an assistant professor of computer science here at Purdue, and Inseok Hwang, a professor of astro and aero engineering at Purdue. And our moderator for this panel is Professor Dan Hirleman, who's the Executive Director of International Advancement and a Professor of Mechanical Engineering. Dan, it's yours.
Thank you. Thank you, Joel. And it's great to be with you all today. Thanks for joining us. Great couple of presentations earlier and thrilled to be involved in the first panel. As Joel said, we have a great group of panelists, but our topic is Aero-Cyber, aerospace, aeronautics, aviation, and embedded systems and the resource constraints thereof. And certainly all mobile systems, I think, have embedded attributes, and that ends up with resource constraints on energy, on memory, power, all those things. And so, and that's a challenge because our threats, our cyber threats, are often working in unconstrained domains with very large resources to go after us, especially nation states. And so that translates to significant challenges for designers and operators of these systems. So that's generally the topic for today's panel. Very briefly, there is an organization, a new one that's just stood up that's related to this area. It's a Space ISAC, Space Information Sharing and Assurance Center. It's been going for about a year. Purdue's a founding board member, and several of the CERIAS members on the founding board are Northrop and Lockheed, Microsoft, Boeing's on the board, remember, Raytheon, Applied Physics Lab. And there's only two universities, Purdue being one, on the founding board. And that group works in this area, kind of an industry-centered activity, whereas CERIAS here at Purdue is more of an academic-centered activity. There's a couple of working groups in that. I co-chair one on our research and technology for cyber physical security and space systems, and one on workforce. And so I snuck in a couple of questions to ask our panelists about those two things. So if you're interested in that organization, Google Space ISAC or email me or chat me and we'll talk about it. But before I introduce the panel, the format for today, we have an hour. My 5 minutes is about up, so we'll get down to business here in just a minute. We're asking all of the panelists to give us a sort of a position statement, 2 or 3 minutes, share their perspective and position on the challenges of resource constrained embedded systems for mobile, aero, and space systems. After that, I've shared a set of questions with them that we'll try to go through, maybe informed by some of their points of view, and that'll go for 20 or 30 minutes. And then the last 10 or 20, we'll have a chance to take audience questions, and I assume Joel and I will somehow co-handle that and get to your questions as well. So with that, let's start through our group. And again, Joel, thanks for introducing this group. So John Boeing, I'll turn it over to you and for your introductory remarks.
All right, thank you very much. Can you hear me? Okay, awesome. So I'm John Bush. I've been in Boeing commercial airplanes for 30 plus years, and I've been in cybersecurity for 10. So we've been working along, just like Dan was saying, we actually founded 5 years ago an aviation ISAC that got put together to concentrate on the aviation piece of the information sharing. And now, you know, with space, the thing about really in aviation, cyber is just an attribute, you know, like they were saying, cyber plus aero. It's really the other way around. It is functions, and then cyber, we're using this technology to effectively do the functions that we want to do. So the emphasis is very different, you know, it's an afterthought. 10 years ago, it was like, we don't want to know about cyber. You know, lots of hacks have happened. People have got their credit cards. Now the question is, what are our cyber requirements? And it's very different in the aviation world, because at Boeing and an OEM, we work at a very airplane level set of requirements, but cyber is down at the implementation. And so you have people using the same language, but they talk a lot. So a lot of it is about awareness, trying to get people to understand and stuff. The other thing about aviation is, like, when the ground communicates to the airplane, it's via voice. There, you know, there is some digital communication, but nothing about encryption, nothing about message authentication or any of that. And these things have been around, you know, voice since the 40s, digital communication since the 80s. Now we've got ADS-B. There was just a mandate on that. There's no encryption in that signal. There's no authentication in that signal, and it's just been mandated. So cyber is really an attribute that is growing in aviation and has to be there. But, you know, it's going to be, you know, we're still at understanding the big context, you know, down to the details of doing that. And so it's a very interesting area. You know, I'm glad we're having this panel to talk about it, because I think it's going to be very good. Back to you.
Thanks so much, John. And now I'll turn it over to Dr. Celik from Purdue as well.
Right. Hi, everyone. Thanks for being here. I'm Berti Selig. I'm an assistant professor in the Department of Computer Science at Purdue University. So mainly, my research investigates the design and evaluation of security for software and systems. Specifically, I focus on emerging computing platforms and the complex environments in which they operate. So my research approach is basically best illustrated by my work in safety and security of Internet of Things and cyber physical systems, also in robotic vehicles and automotives. So I'm very glad to be here. We have a couple of projects going on. What I see is recently the aerospace industry have well recognized that they need to move faster towards the digital feature. So this means that the companies adapt technologies by using different sensors and actuators from different manufacturers. And also they integrate some edge computing or cloud computing technologies, which drives the efficiency and correctness of their products and services. However, during this process, these developers or the system designers needs to understand the system in detail, as well as they need to have some set of security skills in order to make the trust and their threat models very accurate, so that they can understand the threat space of their products and develop some efficient techniques against them. However, this is challenging because these systems are oftentimes very complex. And on the other side, the people who are designing this mostly focusing on their efficiency. Maybe they are eliminating some design perspective that would make these systems safe and secure. So I see that there is a gap here. Additionally, what I see is because these systems integrate multiple different components, which are able to work in both digital and physical domains. This also introduces new attack vectors to the adversaries and new challenges that we should consider in order to create efficient defenses.
Great, thank you. Thank you so much. Our next panelist is Michael Gahn. He's a mechanical engineer, which proves MEs can do anything, I think. Fellow mechanical engineer, and but also he's really the executive sponsor for our Purdue Rolls-Royce PhD Cyber Fellows program and the consortium. So thanks for all you do there, Mike, and turn it over to you.
Oh, thank you, Dan, and thank you on behalf of Rolls-Royce to be on this panel today on this important topic. So when you think of Rolls-Royce, I'd like you to first think of power and propulsion systems such as jet engines and not as cars, even though we share the same name and logo. So just to set the stage there. Our customers on the defense side with the Department of Defense in the US and the MOD in the UK and civil within FAA and EASA are fortunately increasing our cybersecurity as important as John recently kind of mentioned. And our latest announcement on the B-52 win on the commercial engine replacement program, there was a threshold requirement on cybersecurity that you needed to meet even to be considered as a competitor on that program. So it is absolutely an attribute that's growing within aviation and aerospace. So, I'd like to just mention a little bit about myself. So I've been at Rolls-Royce 14 years, and as Dan mentioned, I am a mechanical engineering and an aero engineer by trade. And I've only been in cyber here for a few years, but prior to that, I was with the U.S. Air Force and the U.S. Navy. So, and it's great to be here talking about this subject today because our collaborations with universities and governments are what's really going to enable us to move forward and secure the aviation space.
Great, thanks, Mike. And now, Professor Hwang.
Hi, I'm Inseok Hwang in the School of Aeronautics and Astronautics, and my research area is autonomy and controls, and especially focused on the higher assurance autonomy for cyber physical systems with application to, the aero department, so the aerospace applications. And my focus is on the cyber physical systems, and our traditional systems are typically physical systems, but nowadays, due to the rapid advancement in computing, sensing, communication technologies, our used to be dumb system becoming ever more intelligent. And to be intelligent, they are relying on sensors, onboard sensors, and communications. And this opens up the door for the new challenges in the area of cybersecurity. As John just mentioned, he's in the aero department, so in aero industry. So the airplane, traditionally, we don't care about cybersecurity. I never heard about cybersecurity when I was a graduate student, for example. But now, the cybersecurity getting more important in this area because just like IoT, airplanes get connected to other airplanes, and also new types of airplanes now and will be operated I think soon, such as the unmanned aircraft system, say drones, or the air taxi, we call the UAM, urban air mobilities and personal area vehicles, and all sorts of different these vehicles, and highly rely on autonomy. And this autonomy, again, as I said, that relying on onboard sensors and communicated information from the ground control station or from the other vehicles surrounded in the neighbor. So the different from traditional cyber systems where the computer science, the scientists work on a lot, and the information security, for example, encryptions, authentications, all these. And in these cyber physical systems, if you lose the security or breach some part of the security, then not only we lose the information, and more importantly, we can suffer from the property damages and even human losses, because airplane can crash or hit the other airplanes or hit the building, just like 9/11. So if you consider how dangerous the system could be if a serious cyber attack happens, breached into our autopilot systems, our systems. Again, this is also applicable to ground system too, the intelligent cars, and there are many accidents, incidents, and simulated incidents that hackers can crack into the automobiles control systems and stop the car and accelerate the car, hit the buildings, and all sorts of things can be possible. But unfortunately, so far, the cybersecurity never ever been seriously considered, so that the communication channel, for example, the UAVs and the urban air mobilities, even the commercial airlines, they use not only voice communication channel, but also data link. John mentioned the ADSB is not encrypted at all. And also drones using the specialized communication protocol or link, a MEV link, is not encrypted at all either. So again, this opens up the doors. And then, since I'm in the autonomy area and controls area, different from the traditional cybersecurity, again, such as encryptions, authentications, my interest in this autonomy domain is that, can we design an autonomy system, or including the health monitoring system of the physical system and the autonomy controllers, even model-based one or nowadays AI-based ones? Can we design such algorithm can still operating within the allowable range under cyber attack? If there is a cyber attack, system is vulnerable, can it tell by analyzing the system even before they are implemented? And then the next step is that if cyber attack is feasible, how severe certain type of cyber attack will be? It can crash the airplane, it just slightly perturb this attitude. I mean, severity widely varies. At the same time, then if attack is possible, can it detect it? Some attacks are well designed, sophisticatedly designed, such that it can bypass the monitoring system. We call such attack as a stealthy attack. And stealthy attack can be possibly designed bypassing again monitoring system. And so, if so, can we design the monitoring system more sophisticated to counter it? And also, eventually, can it design cyber attack resilient autonomy control algorithms such a way that even if there is a cyber attack, system operate more or less safely, even though the performance may be degraded, but still separated, they operate and then safely, land. And that sort of thing will be very important, and that's what is my research area. Thank you.
Thank you. So now we'll go into a set of questions. I'll try to help balance it. The first one's, I know we're all running as fast as we can to stay even, but if you took out a crystal ball and kind of looked ahead, what do you see coming in the next handful of years, few years, in terms of trends that are going to change in some way the job that you're trying to do? So let me start with John and Mike from the industry's perspective of what trends do you see that's changing the job you're having to do?
So a lot of what's changing is just the awareness of cybersecurity, and the regulators and the operators, the environment that we work in is becoming much more aware that cyber is a major threat issue. And the fact that we have been transitioning our data, more of the airplane systems, to commercial off-the-shelf airplane systems. When I started as a young engineer, we had these things called ARINC buses, and they were aviation specific, just made for aviation. Now we are using Ethernet and Ethernet based things that, you know, are where all the vulnerabilities are, and using operating systems that are based on, you know, commercial operating systems versus very unique ones that we used to use. And so there's just the threat surface is just getting much larger and more functionality. So I think that's the big trend, is that it's just going to be more impactful. But what is really important is to really understand the context. Like Professor was talking about attacking the control surfaces. We have so many layers of defense that would be very, very difficult on a big commercial airplane. On a small drone and some of the urban air vehicles, maybe not. You know, and that's kind of an area, you know, where there's going to be all these new entrants that are going to want to use commercial off the shelf and that. And we have to be really diligent in our cyber work to make sure that those things stay safe. So the whole airspace is safe, because we all share the airspace. There's only one airspace. So it's going to be, you know, it's going to be a challenge, and good.
Indeed. Hey, thanks, John. And my first internship was with Boeing, working on a database in Fortran. So I go back a ways with you.
Oh,
Mike.
nice.
Yeah. Who did you say, Dan? Okay. So from our perspective, there's two different engineering mindsets and skill sets that are converging. And this was hinted at by one of the professors here. One is safety, which is deliberate in its pace, and cyber, which needs to move fast to keep pace with the attackers. So there's no easy solution of how we handle this. The differences arise not only from engineering teams that develop and design, but that has to continue through the verification, validation, testing, and evaluation through in-service operation. However, we need both, not just one or the other. And I'd also like to point out that in Aero, we have very large lifespans in our products. So common consumer electronics and IT equipment are expected to have be supported for five years, maybe 10. Our products are expected to continue flying for 20 plus years and even longer on the defense systems, sometimes up to 50 years. So what technologies, threats, and capabilities and strategies will be present then? And then one positive trend that we have is that increased focus that John mentioned from our customers and the industry, coupled by our ability to make very bespoke systems. So I'll end with that.
Great, thank you. Why don't we move on? We'll have the faculty take on the second question for us, and then of course, if John or Mike, if you want to jump in. This is about knowledge gaps. What's hindering us from doing as much as we need to do today and in the future on assuring these space cyber, global transportation cyber systems? And what are the sort of the research and technology needs that can help fill those gaps? Let's start with you, Professor Celik.
Yes, sure. This is a great question. So the gaps, right? The knowledge gaps. So what I see is in order to secure a system, we need to first understand how that system operates, right? And we need to do this in detail at both the system level and also the application levels. Thereafter, we need to conduct threat and trust model assessment by asking a set of questions. So these questions might be like, what are the assets that we are trying to protect, right? What kind of threats that might be this system face? Or can we envision any feasible attack that would violate any our security goals? So mainly the answer of these questions is called a threat model, a characterization of threats that the system must deal with, right? This will, after we define the threat model, this will enable us to identify fundamentally new algorithms, techniques, and tools to design, and build and operate these techniques in order to have secure systems and protect our critical infrastructure. However, there is a gap between understanding these systems and also the training and education of the individuals about the security of these systems so that they can ask the right questions, right? So without having this understanding, we are missing some threat models, or we are missing some parts of the threat model that kind of prevents us from developing efficient techniques. Especially, I see this gap in aviation, because maybe the institutions or students do not have access to this type of like the real operating devices or their test beds or their simulations at all. Right.
Thank you.
So,
okay, thank you. Inseok, could you weigh in as well?
Yeah, I agree what the Berkay said, and on top of it, I want to say that cybersecurity, as I mentioned, the cyber physical system, cyber domain, traditionally computer science, the area, and then the physical systems, aero-mechanical, domain. So multidisciplinary effort is the gap. Even though some of the problems are well recognized by both communities, their language is quite different. And it turns out to be that we are talking about the same thing, but we could not understand the others' ideas and concepts because of these language differences. And then the awareness, as John mentioned, that now the awareness growing in this autonomy group, and so that our students get more used to or exposed to the computer science concepts and ideas and how the system is operating, as well as our traditional domain of the physical systems, dynamics, differential equations, and so on. But many times students lacking that, the different conceptual model is used and concepts used, and different mathematical tools are used in the computer science. So bridging the gap is typically what I have encountered by interacting with the industry, the national, the agencies, people, and then our students. So the interdisciplinary or multidisciplinary aspects, I think, is nowadays the gaps that we have to fill.
Thank you. Now, Mike and John, let me say, if you had one silver bullet to fire at a gap somewhere in the technology domain that you deal with, what would you fire it at?
So I don't think there is one silver bullet. And 10 years ago, that is what all the managers were asking. And that's what industry was asking. What is the one silver bullet? And cyber is an onion, and there are different layers and different pieces. So, the one thing I wanted to say to you and all the students is cyber is still so new in aviation and stuff. Anyone here that's taken a cyber class has more formal education than I do. I have never had a formal cybersecurity class, and a lot of people in aviation don't have that. So this is a great place to come in and take that knowledge, even if it's just, and really understand the context and understand, because we deal from anything from supply chain, chip vulnerabilities, up to big systems, talking, systems of systems, and all the things. We have all these different layers, and it's really hard to say one thing. I think awareness is really, it's not a technology, but it's really something that's important that I think everyone still has to be able to figure out.
All right, Mike, you get a silver bullet. We don't know where we get it from, but what do you fire it at?
I'd like to echo a lot of the things that John mentioned. Aero-Cyber embedded systems are not like IT systems, and we usually have bespoke processors and modules due to the environmental constraints that these things fly in, and they're much more resource constrained. So a lot of the common security approaches that are out there, they need to be developed, adapted, and integrated into our systems. There's nothing that's really bolt on. So, and I will absolutely second the lack of any kind of cyber formal education. Because a few people on our team do have that, but not many. And so there's a lot of unique R&T needs, and it covers the whole gamut of the NIST cybersecurity framework, from protect, detect, or identify, react, and recover. And I think the key thing I'd like to stress is, because it's so new, you really need to have the people that we're looking for need to be good communicators, have good emotional intelligence, because a lot of times it's as much of an influence campaign across all the different disciplines that go into building that system, such as the supply chain or the different components of the aircraft and products. And having those good EQ skills and good communication skills is very, very helpful.
Okay, thank you. All right, I'll switch
Yeah,
to another.
I'd like
Go ahead,
the
John.
EQ skills, I think, is extremely important, because we are a cost. That's a resource limited thing. And so if you're doing cyber, you're not going to do some functionality. And so your job as a cyber person is to basically say, no, you can't do that. You have to do this. So EQ is really important. It's a thing I wish I would have known 30 years ago in school, because I would have taken more classes on that, because that, especially with cyber in aviation, it's really about emotional intelligence. That is really important, and being able to talk with everyone and understand what's going on and being able to influence people just by talking is really key.
Great. Okay, the next question is about the asymmetry between the threat actors and our embedded systems and the teams of people working on them. So how do you see, I mean, you're surmounting that challenge these days, but it's only going to get worse. How do you think about that asymmetry, how fast the threats are moving, how fast can we move? And I'll just open it up. If you want to jump in on this, just wave or start talking and take an opportunity to add to this. John.
I'll wait to get it going. I think one of the things, at least in aviation and around airplanes and how airplane systems are put together, is that we really limit the threat surface. So there are very few entry points for people to get into the system. So even though the hackers are going much faster with unlimited resources and that, they have very little ways to get into the system. So that's one of the things. But just like we found, when we built the 787, it was spec'd in 2004, 2005. It had like SHA-1 hashes. Now, in the 2020, that is not acceptable anymore. And so it has to change. So we do have that, legacy thing that airplanes will need to learn to change much faster, but we have a slow, deliberate safety process that has proven and driven out accidents over the last 50 years. So we need to continue doing that, and be very diligent in how we split that up, so that, because hackers are getting much faster and better and stuff. So we have to limit our threat surface and be very cautious and deliberate about what we allow it to happen. Because you don't log into an airplane to fly it. Now, you will with UTMs, and so that's going to be a different thing. There's a whole new market where that's going to happen. But right now, when you go to the airport, your pilots aren't logging in. So we do have that safety built in.
And so that's sort of the embeddedness turns into an advantage from that point of view. You naturally have a smaller threat surface. So I guess that's a plus, an upside. Thanks, that was a good one. Anyone else want to talk about the asymmetry and its trend and how we battle it?
So I would like to add a couple of things here. Even though, like as it is said, the threat surface might be like smaller than the other traditional competing platforms, but what I would say is there are like many different threat actors, but I guess particularly in aviation, these threat actors might be the part of the advanced persistent threat groups, which are very sophisticated, well-funded, and strategic groups, right? In that sense, I guess, so we should not underestimate the attack surfaces by just saying that, you know, it's difficult because we are recently seeing that these APT groups, advanced persistent threat groups, can able to attack the water treatment plants or the power plants, etc. after like working many years or even applying some psychological attacks to some workers in order to, you know, like use them as a stepping stone to go inside and the companies or their software systems.
Great, thanks. Any other thoughts on that question?
I think like one of the, you know, when I think about what can we do to help with that is we have to be agile and able to adapt. And this is not just from technologies or methods or designs and software sort of perspective, but also from a team's perspective and in our thinking as well. So, you know, the systems we ship are resource constrained, but, you know, the whole of our business is not. If we limit our view of security to those things that are in our products alone, I think we might be unnecessarily limiting ourselves in ways that our attackers aren't.
That's interesting, yeah.
And for me, the aviation domain also grow very rapidly by incorporating variety of like different types of vehicles, including drones. And so to accommodate these many drone operations safely, especially urban environment, the concept called the UTM, UAS Traffic Management System, is proposed similar to ATM, Air Traffic Management Systems. But this is more rely on the technology than human. So different from the traditional commercial airlines, their systems are the data link connected, and also the registrations are all, you know, data driven and so on, so that it is more vulnerable to cyber attack than the traditional the aviation domain. So that's a growing effort. So the one of my projects sponsored by NASA is the how we design a UTM system in such a way that it is not only safe as the ATM system, but also is secure, so that the its safety level can be maintained, just like our traditional legacy, very safe aviation system.
Great, thank you. I'd like to, it was brought up a bit earlier on a couple, but I'd like to then go to kind of the workforce education and training. What changes, you know, some things have happened over the 30 or plus years that some of us have been out, but what are your recommendations on workforce development and how the universities as one element of this, of course, continuing education and others. What are your recommendations on workforce going forward?
So I think one of the key things, and it's been mentioned a couple times already, is we need a cyber-informed workforce. And so it's not just people with cyber and a job title, but it's software engineers, electronic engineers, systems engineers, and program managers and business people. We need to reach outside of our typical cyber majors and help other skill sets see how they contribute to producing secure systems. And I think from a, you know, this is really akin to the cross-functional and cross-disciplinary nature of CERIAS, you know, that you guys pioneered and in security here. We also need to continue the collaboration between industry and academia, and This not only helps solve the hard problems, but it introduces students to the types of problems that industry faces, and gives them practical experience while developing a talent pipeline. So I think that hands-on work will be very critical, especially in this near term, as we try to staff up to address this problem.
John, any comments from the Boeing perspective, or like your perspective?
Yeah, so we've been hiring people left and right. And so we've just, we've been talking about what kind of training do people need and where do we need. With us, a lot of it is understanding our aviation context and how aviation regulations and stuff. Again, we're using the computer technology to do functions, to fly airplanes, to communicate. We're not using it for users to log in and surf the web and stuff. So it's an embedded system. And so even though you have authentication and authorization, it's used very differently. And it's really systems engineering is really a big thing. So having understanding the whole systems of systems and very complex and being able to describe it in detail is really important. The cyber piece and understanding that, I mean, that gives such a great foundation for people for system engineering and stuff. But again, being able to look at other people's perspective is really clear, because you have to influence people and you have to understand what they're doing, because they won't have, you go talk to someone that works TCAS or in-flight entertainment. They have no idea. They understand, oh yeah, it's networked together, there's an IP address, but they have no idea what that really is going to mean from a cyber standpoint. And people that have the knowledge, you have to explain that to them. So really learning to be a teacher and explain these hard concepts to people is really kind of a key piece. And that's probably not, it's not all the academic classes. It's the part of being a full engineer, and a total person. That's really kind of key.
Thank you. Inseok, you've been leading in what will I say, adding a cyber-informed mindset in aerospace engineering, for example. How's that going, and what are your thoughts on going forward on changing our education?
So the still struggling in the sense that our students, say for example, the students are, is this really aero engineering stuff, right? This is the computer science stuff, and why we have to pay attention to this type of one. So get them motivated is very important part. So today and tomorrow and the day after tomorrow, we have this special short course that Mike Francis, who's retiree from the DARPA and the Lockheed Martin and so on, he's teaching this autonomy in the history of autonomy in the aero applications. That kind of special lectures could be good for, especially for undergraduate students who do not have any motivations on this autonomy in general, specifically cybersecurity, and get them exposed to how serious autonomies are, and then how important autonomy is in aero industry, along with the cybersecurity. And also by nature of this multidisciplinary aspects, so students getting some courses from, say, the computer science department and stat department, and also ECE department, the AAE too, ME too. So this opening some of the class requirements open to the other department, even across the College of Engineering and the College of Science, would also help enhance this cyber-focused education. And so that's what I have found, and we are trying to achieve, from the past and the next few years. So.
Okay, you come from the computer science side, and I know you have students from other majors in your classes. What are your perspective on this interdisciplinary mindset and education going forward?
I think this is an extremely important topic, and it pays off in like 5-10 years, right? We need to execute something and then we will see the benefits, not immediately, but later on. So there are multiple ways which I believe that the education and workforce training that we can follow. So I would like to give you a couple of examples. For instance, I believe that like both academia and industry may work with like some K-12 teachers, right? In order to introduce to these high school students some computer security or these emerging technologies. Maybe this can be integrated to their curriculums, or there can be like some corporate visits that you can show around. And because these are all young generation, I'm pretty sure that there will be like multiple students will be influenced on these the content and also the visits as well. Such an computer security literacy would provide some opportunities, such as they would in the future follow some STEM career pathways, right? Also, even though they don't follow this, at least it will give them an awareness of in the context of societal implications of security and how these systems are used. Secondly, like in the university, for instance, we have like a lot of theoretical concept that we teach in our classes. However, like seeing a kind of like a real world example, or maybe it's just like a testbed system or it's simulation, what I see is students really learn fast. And when they apply the theoretical, the topics that we have seen in the class to those systems, such as, you know, like finding a bug or making a plant stop working, they really enjoy this. And they also work like teams with teams of groups. I see that this will also allow these students to look for jobs, not directly going like software engineering to the big companies, but looking for other opportunities, maybe just working in that domain, any cyber physical systems. So as a faculty, what we do is we are trying to, you know, like get some systems, some test beds to our laboratories to give an hands-on experience. We use these systems for research, also try to integrate these systems in our courses as well. And whenever there are like some opportunities in our department, like aspiring girls, or sometimes like in summer high school students comes and visits our department, we kind of demonstrate these systems to these students in order to achieve the previous goals that I mentioned.
Thank you. Now we'll turn to the audience and put in your questions in the chat. But first, if the panel has any questions they'd like to pose to one another, that's you can jump in as well. But there is a question that's come up about, I guess it'd be prevention, shall we call it? So global laws can laws related to cyber crimes and cybersecurity, can they make an impact in this domain in your opinions?
So I'd like to say laws, well, hackers aren't going to follow the laws, so I don't think it matters. What really matters to us is getting the right regulations so that we design cyber safe systems, and we get the lawmakers and regulators to understand, to have a better understanding of what cyber is and how it is, because it really is a different viewpoint and a different reality. Safety is all about functional hazard assessment. 10 to the minus ninth is safe. It's deterministic. Cyber's not deterministic. It's going to be the same emerging thing that we have with the autonomy and the AI and that type of work. You know, we're going to have this fundamental shift. And that's what's really exciting about this, is that, you know, fundamentally, we're going to have to shift over the next 5-10 years to a different way of viewing things. And cyber is just one piece of it that's going to be very interesting.
Agreed, John. So if you had to guess, and I'll let you take this question in whichever direction you would like, but in the next 5 years, so certainly long-term, but not an extreme long time, where is the area that you believe is probably going to have the most advances in cybersecurity for the aero industry? I bring this up, what spurred my question is that Mike Gahn, Rolls-Royce, and I have been working on a couple of projects that are looking at adding AI systems to cyber intrusion detection with some of these systems. But we've had some very deep conversations on what are the areas that we're not thinking about that may have tremendous asset to Aero-Cyber. So if any of the panelists have comments on that.
So I think from an overall aviation industry, what we talked about with the urban air mobility and the UTM, because that is computers working with computers to keep people safe. And currently, like I said, with air traffic control, we basically keep people safe by people monitoring something and people talking to each other. So this whole shift to where it's a computer talking to a computer is going to be the area. How do we do digital identification? There is no standards, no international standards or any kind of standards for that. You know, we just released a system, ADS-B. There's no authentication. Anyone can spoof it. You know, cyber hasn't been thought of. I think that's the big area, is that cyber will get into these different areas. And the ATM, UTM is going to be the first area that's going to pull the rest of us dragging with our heels in the sand into the cyber digital world.
Interesting comment, John. I relay that to some conversations we've had with other serious partners that are not necessarily in the aero, more in the astro, and actually some in the aeromotive, and very interesting thoughts that actually align with some of these others that are dealing with, as I return to my opening comments, this cyber plus, what is some of these other areas that are not in IT that are dealing with these things. Inseok, I know that you have dealt a lot in there. What in your research are you seeing that may be areas of potential gains that we could see within the next 5 years or so?
So the two things, one is the application domain in aero industry that I chimed in with John. So UAM, UTM, and ATM areas are the fundamental areas that we can see a lot of improvements in there. And these are mainly as you mentioned, that mostly automation-based operations. And then everybody connects to everybody, opens the door, no communication protocol. There are communication protocols, but no encryptions and nothing, safety security measures taken place. Even though they are now start looking into the problems. So some advancements, and then the government setting up some regulations and the rules and the guidelines and so the industry and research institute and then the academia work together to come up with technologies to address those areas. And another one is that now machine learning AI-based technologies has been advanced so far. But at the same time, our systems different from the traditional AI domain. For example, the face recognition. There is no dynamics, but the vehicle follows Newtonian mechanics. We know that for the last 300 years. Why we ignore as if we do not know anything? And then I'm thinking my perspective is that this model-based approach plus data-driven approach, and each method can complement each other's work. And the model-driven approach, traditional analytically driven approach, has a lot of good things in the sense that we can prove its property. We can guarantee the properties mathematically, not just the simulations. But machine learning-based one, if it is working well, it's working well, but nobody can say it's definitively working in that way under any circumstances. That's very, very, very challenging area, right? So formal verification, validation very important role, especially aero industry. Certification is a big part of it. and certifying something is very, very difficult. So that area will be a very, very important area, and we can see some advancements if there are any significant advancements in those areas.
I would say that any sub-industry would welcome the opportunity to have some cybermetrics that actually quantify exactly how secure we are.
So, yeah.
But that's a topic for another panel discussion.
Yeah, important.
So, Berkay, in computer science, and I've had obviously the pleasure of getting to hear you talk before in some of your specific research, but when it comes to hardening controls or the control systems for some of these aero systems, is there an area there that you think we can take some monumental jumps in the next 5 years or so?
Yes. First of all, I mean, it's all technology. What we see recently is being like automated, right? However, like in aviation, because they are exposed to physical domain, right? There are many uncontrolled, I would say, noise or environmental factors, right? So this kind of makes very difficult to model the correct operation of the system. So once we have the correct operation of the system, anything deviates from that correct operation, we would say that either this is caused by an adversary or maybe this is a fault, right? So what I see is, because we are trying to make everything automated, we need to also test these systems in order to see their operations are correct. However, historically, we also know that these systems are complex. So it's very difficult to model these systems, or it's very difficult to verify whether a property or requirement holds on this system or not. This is because it has a very huge input space, and there are some non-linearities, and the systems are non-deterministic, and also they have a hybrid nature, right? So what I see is the model-based design, the model-based abstraction of these systems becomes very important, which I see that recently they call it like a kind of digital twins as well in some cases, right? It's a kind of virtual replica that you can run and then see the real operation of the system, and this virtual replica are like correct or deviates from each other. Of course, this requires a set of technical skills, like how we can abstract, how we can analyze the source code and then create a model. And then after we create the model, how we can ensure that this is realistic, and how we can develop some approaches in order to run on these models to test these systems. So models has like multiple different purposes. That's what I see. And this model is basically extracted from the source code, because the source code manages its behavior. In that sense, the model design, the program analysis techniques, the fuzzing techniques in order to find these bugs, and formal verification techniques in order to ensure formal safety and security guarantees, I think becoming extremely important, because we cannot just give inputs and test these systems. It's not safe, right? And the input space, as I said, it's very huge.
Mike, I want to change up the question a little bit for you, in that CERIAS and Purdue is very proud and pleased to be part of the Rolls-Royce Cyber Technology Research Network, along with our peers at Scilab at Carnegie Mellon, and then a university to be named in January. Very exciting. But this is a monumental program that Rolls-Royce has decided, okay, we're going to partner with just a handful of universities who have deep expertise in Aero-Cyber to help address these problems. So from your perspective as kind of the program manager for this entire research program, what are your kind of those intermediate 5-year out? What are you hoping that we can solve? I don't think that we're going to solve all of the cybersecurity programs for the aero industry, but what are you kind of considering this low hanging, or maybe not quite low hanging fruit, but that you're hoping that we can make monumental increases in contributing to the security, the cyber physical security of Rolls-Royce products?
That's a good question. So there's a number of different areas that we're interested in that could make big changes. in the security of our products. I think there's different components to that. You mentioned the AI bit. It was mentioned earlier, MBSE and digital twins. Those are all areas I think are ripe for research, and that could make things, especially in these embedded systems that fly around, much more easy to understand if there is an intrusion in the system. But they are complex, and those are not trivial problems to solve. There's also, I think that, I just lost my train of thought, so apologies there. I think that the other pieces that we're looking at, one of the key foundational pieces is architecture. And it hits from both the certification side, that safety versus the security side. There's lots of things that we could probably do better to help be able to move at pace of the attacker while maintaining that critical safety aspect of our stuff, of our products.
Well, thank you all. I think we have hit the ending point here. I really appreciate each of the panelists bringing your expertise to the table, unique perspectives, and I thought it was a great panel. So thank you all. Turn it back over to you, I guess, Joel, to set up the next panel.
Great. Thank you, Dan, and thank you for being the moderator on this very interesting panel.